Hello everybody, welcome back to OWASP Algiers Chapter 2nd Web Application Firewall Training Session presented by Mehdi Sammar. Last week, we kicked off the training by introducing what WAF is and its operation mode and various deployment models. We also covered several details, use cases to help you understand how WAF protects against web application based attack. If you missed it, you can find the full session on YouTube channel, including the hands-on lab we completed. Now we are diving into a more advanced topic as Mehdi Sammar will guide us through the next phase of the web security device. Without further delay, let's hand it over to Mehdi to continue his exciting journey into the web application firewalls. So Mehdi, you can start, please.
Assalamu alaikum, everyone. Hello. Thank you, Hisham, for the introduction. So quick introduction. Again, it's Mehdi Sammar, a network security consultant. So I'm doing this job for more than almost 10 years now when I started my journey in cybersecurity. And now I'm delivering projects and training related to network security and cybersecurity in general. Now, what is the goal of today? If you remember, in the last session, we discussed about the WAF deployment, and we tried to focus on the, oh, sorry. I think my screen is freezed, right?
Yes, exactly. Mehdi.
Oh, sorry.
Okay.
Okay, now let me start over. So it was the who am I? So I said that we discussed about the WAF deployment, but we've taken it from the network standpoint. I told you that the goal was to provide you with the knowledge that help you to understand how WAFs are deployed. Basically, what is a WAF appliance, how it's deployed in the network. And the goal is to introduce you to the network side of web security. Because I've seen many people working about web security from the development side, like coding, creating web applications, understanding what is the web-related threats, like phishing attacks, SQL injection attacks, something like that. But to take it from the network perspective, this is what we are doing. So for today, inshallah, we will be talking about first a recap about the first session. So it will take maybe 15 minutes to recap everything that we discussed in the previous session. And then we will introduce in this landscape the relation between WAF technology and firewall technology. In the real life, it's impossible to deploy a WAF without a firewall. This is why it's very important to understand the relation between them, what is provided by the firewall, what is provided by the WAF. And then we will go straight to the practice. We'll try to have a demo that will cover the NAT and firewall policy concepts. So what is a NAT in a very quick way, and then we'll deploy it on the firewall, and then we'll talk about the firewall policies. Now, right after the understanding of the WAF and firewall relationship, we will move to a deep concept, relatively deep according to the concept we have seen now, is what we call the X forwarded for header. So why do we need this X forwarded for concept, and why it's important to use it in WAF deployments? And right after that, we'll have another demo for configuring the X forwarded for header. So today's session will be more practical than the previous. Okay, the previous was more like about the basics, the theory behind the concept, and we got a short demo. Okay, maybe it was just 20 or 30% of the time demo. For this session, it will be 50-50. We explain a concept, we practice it, we explain another concept, and then we practice it. Okay, so let's get started. Session 1 recap, key concepts and WAF deployment in a nutshell. If you remember, for those who attended the first session, we focused on the physical deployment of a WAF. And I told you that we have just two physical deployments. The one we call the inline, which means that the WAF is always deployed with two interfaces, one facing the internet, the other is facing the data center. Now, the internet means that it's the network hosting all the application clients. Now, the goal behind the inline deployment is to force physically the traffic to go to the WAF. It will be inspected. Then a new connection is established from the WAF to the backend applications located inside your data center. The other physical deployment is the one arm. And we said that this helps the WAF to get a copy of the traffic in order to inspect it in an offline way. So the goal behind the one arm physical deployment is to have your internet. This is your data center. Again, this is your data center. You have a network device between them. For example, a router can be a firewall, a switch, and the WAF is deployed not on the path. We call it also the out-of-band deployment. Now, the goal behind this deployment is to just send a copy of the traffic to the WAF for monitoring reasons. And this is the main reasons to choose one of these two the physical deployment modes. But remember also that we said the physical deployment can support multiple operation modes. Okay, it's very flexible. We can have an inline deployment with different operation modes. The 1R deployment was also different operation modes. So what is the operation mode? This was the second point that we discussed. Remember, we discussed about the reverse proxy, and it was the most important operation mode. And to make it pretty and simple, remember that it's always about IP connectivity. A client initiates a connection to the WAF. Whatever the WAF is inline or one arm, remember, the reverse proxy supports both physical deployment modes. And then a completely new connection is established from the WAF to the backend web server. So the reverse proxy is the most secure and it's the most flexible deployment mode. The only issue with that deployment mode or this operation mode is that it requires a network change. If you have your web application running without a WAF and you decide one day, so you are in this situation, your web application is directly reachable from the internet, and one day you decide to make it go through the WAF. In this situation, you have to reconfigure your network. Most of the time, this is done on the DNS, it's done on your firewalls. So you can configure the traffic to stop going directly. Instead, it will go to the WAF, and then the WAF initiates a new connection to the backend server. Remember, the only negative side of this operation mode is that it requires network change. The two other modes are the offline. And remember that we said the offline mode supports only the one arm deployment. It never deployed inline. So as I said, we always have traffic going to your backend server and a copy is sent to your WAF. The most important part of this deployment is monitoring. Your goal is to monitor, not to block. And a very interesting characteristic of this deployment mode is that it adds zero latency. If you used to access your web application, for example, with a latency of 50 milliseconds, adding an offline WAF will keep it exactly with the same latency. No hop is added to the network. The last part, so proxy, reverse proxy, and then offline, the last operation mode is the transparent. And we said that the transparent deep operation mode, supports only the inline deployment. So you always have your WAF connected to your backend servers, connected somehow to your clients, and then the connection is always initiated toward your backend servers, but the WAF is just proxying the session. From the IP's perspective, it's always the client who is the source and the server is the destination. The WAF is never involved in the IP communication. And this is why we said that the WAF deployed in a transparent mode uses no IP address. It has no IP address except for its management capabilities. The WAF in this situation operates more like a layer 2 switch. Okay, it uses the MAC addresses, it uses the IP addresses inside the HTTP traffic to intercept or forward the traffic. Now, after we understood that, remember that the lab or the demos we have done were using the Fortinet FortiWeb WAF. And I explained how the FortiWeb is configured by explaining 4 different configuration components. The first one, remember, it was to configure a virtual server. And we said, in a very short and pretty way, a VS is just a listener. It represents a physical port, like port 1, plus a listening IP address. And remember that in our demo, it was the 10.1.100. Then, when you configure the VS, you configure a web protection profile. The web protection profile is simply a set of security controls that determines how the traffic should be inspected. Do you want to use, for example, DDoS or DOS policies, XSS signatures, SQL injection signatures, etc.? All the security at layer 7, sometimes also as layer 3 and layer 4, are configured inside the web protection profile. Third component was the, number 3, it was the real servers pool. The real servers pool was a configuration object that contains the list of all the servers you have, plus the load balancing algorithm you want to use if you have multiple servers. The health check, many configuration can be applied inside the real server pool. Now, remember also that when you bring everything in, or when you configure everything inside the WAF, you have to use everything inside what we call in the FortiWeb, the server policy. So the server policy is nothing more than a policy that will listen on a VS. When the traffic arrives, inspects it using the web protection profile, then it forwards it to the real servers pool. So that was the configuration overview. And we did exactly that in the demo. Now, again, with the first session recap, that was exactly the topology that we built. Remember, I already had this ready-to-use Kali Linux, and this is working as my web client. Then it's directly connected to the FortiWeb, which is our WAF here. You can see here the interfaces we used, the IP addresses we used. So everything is pretty clear and simple. The back end, here you see that we have the Web 1 and the Web 2 servers. So when we configured everything, remember that we tested this by using the Firefox browser and accessing to the following URL, the 10.1.100, which is nothing more than a VS. This IP is a VS inside the FortiWeb. When you initiate your HTTP traffic to that VS, the traffic is sent to the WAF. The WAF passes it to the web protection profile. The web protection profile, if it doesn't find any threat, or if the traffic is legitimate, it forwards it to the back-end real server pool. So this pool defines exactly how am I supposed to reach out to my web application. What load balancing algorithm I want to use, what are the IP addresses for these servers, what are the health check policies, everything is configured inside the server pool. So that was exactly what we did. So guys, before we start, do you have any question about this? especially about the demo that we had last session. Any question before we move on?
Yes, Mehdi. There is Amin, I think so. He had a
Okay,
question.
sure.
He's comparing that what is the difference between putting the WAF as a monitoring mode, which firstly the WAF is putting as preventive control. So if we put it as a detective control, is better than SIEM, or what is the difference between them?
With SIM?
Yes. For example,
Okay, okay,
since the two are detective controls.
exactly. Hold on a second. Yes, the SIM in reality is a technology that allows you to ingest different log sources. So the SIM is dedicated for monitoring and log analysis. The SIM is a technology that can receive, I'm talking about the most SIMs that are present in the market. They can receive syslog, for example. They can receive WMI for Microsoft environments. They can receive NetFlow. Sometimes they can receive also network traffic like PCAP files. PCAP. Okay. The goal behind the SIM is purely detection. Now, if you are talking about web applications, the WAF has a small, let's say, it's not like a small SIM, but it can help you with monitoring by presenting you the logs in a nice way. Now, if we try to compare them, we can say that the SIM is a general purpose monitoring technology. The WAF is dedicated to web applications. Number two, most SIMs today, they provide detection, and sometimes they can also provide some response capabilities. For the WAF, the main task is just to protect you and give you visibility. Also, the WAF lacks some correlation capabilities. For people who worked in SOC environments with the cyber operations, they know exactly what we mean by log correlation. They can take different log sources, syslog, WMI, they can bring everything together and they can give you with a final analysis result. And this is not really present in most WAFs. Okay. Now, after this recap, I was really concerned about having this recap because we're going to build on top of that today to understand the relation between the WAF and firewall, and then the X4 4, and also the demo that we will cover today will be just a modification of the topology by adding a firewall in the middle. So first, let me ask you a question. Why do we need a WAF? So someone can tell me, but Mehdi, didn't you say that a WAF is enough to protect web applications? Why do we need a firewall? So Amin is saying that WAFs can work with SIMs simultaneously. Yes, that's the recommendation. The WAF focuses on the detection and the mitigation of the attack, and the SIM is more like analyzing what is happening to try to detect large-scale attacks. Because if the attack is purely using the web as an attack vector, the WAF can detect that. But if it's a complex attack involving maybe some email capabilities, some web access to web applications, that can be correlated using the SIM. Thank you, Amin. Thank you. My pleasure. So guys, why do we need a firewall when we are using a WAF? So let me give you some key points here. We have said from the beginning that a WAF focuses only on web application security, which means that you know that your web application is always, this is my web app, on top of an operating system. The operating system is on top of a hardware. Sometimes it's on top of a virtual system, but it doesn't matter for now. If you want to protect all the ecosystem of your web application, you have to consider also the detection of non-web-based attacks. For example, what if someone malicious wants to use SSH vulnerabilities to access your operating system? If I can take control of your operating system, I can take control of your web application. Okay? It's very easy for an opponent or an adversary to take control of your web applications and sensitive information if it has control over your operating system. What if my web application is using a back-end database? Imagine that I have a DB, which is using SQL language, and the database itself is inside another server. So it has its operating system, it has its independent hardware. What if someone is not going through my web application, but he found a way to go directly to my SQL database? A WAF is not here to mitigate database or purely database related attacks. If the database attack is through a web application, is to take control of the entire file system of your web application. The WAF cannot do the job for that. The WAF is unable to detect SSH, FTP, or purely SQL related attacks, which makes the need for a firewall something very crucial. So firewall control general network traffic. Now, when I say firewall today, this can be sometimes, let's say, ambiguous. Why? Because we have layer 3, layer 4 firewalls. We have next generation firewalls. We have today, many vendors providing very important and very various capabilities when it comes to firewall. But whenever I'm talking about a firewall, I'm talking most importantly about layer 3, layer 4 firewalls. And of course, this is part also of the next generation firewalls that we are using today. Okay, we got another question. So here's me saying, you can use the firewall to enforce some sort of policy to let only you as a sysadmin to access the SSH. That's exactly that. Yeah. Yes, the firewall generally operates at the layer 3 and layer 4. Now, guys, to make it pretty and simple, remember the following. Whenever you have an untrusted network, such as the internet, and at the end you have your beloved web application, the WAF is always in front of the web application, and the firewall is always 100% of the time in front of the WAF. You will never find a firewall behind a WAF. Okay? So whenever someone is trying to access my web application, the goal or the main goal of the firewall is to provide layer 3, layer 4 filtering. What do I mean by that? It means that I can decide to block bad reputed IP addresses or bad reputed IPs. No need for a WAF to do that, because a firewall has full capabilities to block at layer 3 level. Now, also, when I say layer 4, I can decide which TCP or UDP ports are allowed. For example, if I have inside my internal network only a web server, I don't want people to use FTP or SSH from the internet. I only allow HTTP protocol. So I can configure firewall policies to allow HTTP and HTTPS only. So this is the first barrier. This is the first control. So I can block everything which is not web, because I don't want. If I have FTP or SSH traffic, if I have ICMP, Telnet, whatever, this should be blocked by the firewall. So guys, it's exactly like when you're getting to the plane, you're traveling. The first thing is that we check your boarding pass. if you don't have a boarding pass, it means that you're not allowed to get in the plane. So why inspecting you using the scanner? You present your boarding pass. If you have the right to go inside, then we take your luggage and scan it using the scanner. That's exactly that. The firewall is just dropping using source IPs and layer 4 ports. Now, if we have HTTP traffic, the firewall should allow it. When it's allowed, the firewall forwards that to the WAF, and the WAF will apply its layer 7 capabilities to detect if inside this legitimate traffic we have threats. Because guys, when we say that HTTP is allowed, it doesn't mean that everything is allowed inside. So the WAF is here looking for dedicated web attacks, SQL injections, XSS, viruses, etc. Okay, this is why they always work together. Okay, now, the next point is that they always work together to provide this layered defense. Because you know that next generation firewalls today, they can provide you with the next generation firewalls. They can provide you with intrusion prevention capabilities. They can provide you with some antivirus capabilities, application control capabilities. If you want to have a very high security, you can apply a double layered architecture. Like I can, and this is what I can recommend as a security specialist, use 2 different appliances from 2 different vendors. For example, if you are relying on a Fortinet WAF, you can rely on a Cisco firewall or a Palo Alto firewall. So you can apply the IPS from Cisco, and inside the WAF, you can use also its IPS capabilities. One is provided by Cisco, the other is provided by Fortinet. When you bring them together, you have a strongest security. Okay, and this is part of the defense in depth concept. Someone is saying that why we say that firewall goes to layer 7. Today, we're talking about next generation firewalls, and all next generation firewalls today, they can go deep up to the layer 7. Okay. Today, firewalls or next generation firewalls, they are not only firewalls. They are firewalls, intrusion prevention systems. Some of them can provide you with WAF capabilities. They give you web filtering, proxy, many features inside the same next generation firewall. Okay. Mohammed is saying, this is what we call the network's sandwich solution. Yes, I think this term is used in French most of the time. Yes, architecture sandwich. Okay, so can you now answer the question? When I said we need a firewall, now can you see why? Because we need a network security device at the entry of the network to deal with non-web traffic. Okay, FTP, SSH, the firewalls specialize on this. Okay, now, here we can see that the firewall, display everything. The firewall can help you with another concept called the network address translation. So what is network address translation? It's a feature that helps people to access our internal resources using public web IP addresses. For example, do you know that inside your internal network, when I'm talking about the clients, the servers, you cannot use the IP addresses that are used on the internet. So you have to use what we call the private IP space. The private IP space. The private IP space, for people who don't exactly know what I'm talking about, it's the IP addresses that start with 10.00/8, 172.16.00/ let me say just 16 to make it simple, 192.168.0.0/16. These IP addresses are reserved for internal use. So when you have a web application, the web application must be accessible through a private IP. Remember, in our lab, the web application, we have two servers with the 172.16.1.10x, the 101 and the 102. Now, people from the internet, they always use their public IP addresses, which are all IPs except the private space. So all the IP addresses you can imagine, they are part of the public space, but only these are part of the private. So the people, for example, in Algeria, they can come from an IP with the 141.1.1. something. They can come from a 105.11x or something. These clients must use a public IP that are provided for your organization. For example, your web application is published with the public IP 10 or 41.1.100, but this is in reality not the real IP that you are using inside your web server. So again, people from the internet, they are seeing your web applications using public IP addresses, but internally, you are using private IPs. Now, to deal with that, we have to deploy a network device between the internet and the internal network, and this network device must provide you with network address translation capabilities. Most of the time, this is a firewall. It can be also a router, okay? But most of the time, you can find firewalls providing you with NAT capabilities. Now, what is the goal? Again, people are accessing your web applications using public IPs, like 41.1.1.100. When the NAT device intercepts that, it can remove the IP and replace it with a private one. Like it removes the destination 41.1.100 and it replaces it with the 10.1.1.100 from the public to the private. So here you can see that it's typically configured on firewalls. This is what we said. It defines how external users reach the web application. And remember, it's always by doing the mapping between public IPs and internal IP addresses for your resources. Okay, and this is what we're going to do using the firewall that we will deploy. Another key feature that we have to configure in our firewall, is the firewall policies. This is sometimes called access control lists. More like, modern firewalls use the term firewall policies. Legacy firewalls use more like the term access control lists. You can see that it's the same thing, okay? Without getting into the details. Now, what is the goal of a firewall policy? A firewall policy is the configuration object that defines exactly what should be allowed or what is allowed. When we have taken the example in the previous slide, we said that the goal of the firewall is to decide which, for example, source IPs and protocols are allowed to get in. When I told you that FTP, SSH, and other protocols must be blocked, but HTTP must be allowed, how am I supposed to configure that? It's using firewall policies. So a firewall policy is a set of conditions that will apply set of actions if the conditions are matched. Okay, this is not a firewall dedicated training. I will not go into the firewall policies, how they are processed, how they are created, but we will take a very simple example in the demo so you can understand how to configure a simple firewall policy. So far, so good. Do you have any question? So here you can see that it's essential for regulating traffic flow to and from networks. who is allowed to access my web application, who is allowed to access the internet from my internal network. And it's always done through what I called policies. Sometimes they are called firewall rules that specify what is allowed and what is blocked. Okay, I think it's enough theory. Let's get into the practical thing. Let's try to see how it's actually configured. So in this first demo, remember we have 2 demos today, we will first deploy a firewall, a completely new firewall, and I will be using, again, Fortinet. I will use the famous FortiGate, which is the next generation firewall provided by Fortinet. Now, why do I prefer always to use FortiGate in my online sessions? Because it doesn't require a lot of memory and CPU. If you want, for example, to use the Cisco Firepower next generation firewall, the minimum required memory is, I believe, to work properly is 8 gigabit. For the FortiGate with 2 gigabit memory, that's fine. It can work. So it's very quick to deploy, very interesting, and it's one of the leading firewalls in the market. Now, after we deploy it, we will configure the NAT, and precisely we'll configure the destination NAT, and then a firewall policy will configure just one to allow access from the internet to our free shop web application. Of course, and then we're going to test everything. So guys, what is the target topology? That is the target topology. Remember, we used to have our Kali Linux here, right? So Kali Linux was directly connected to the VMware workstation VMnet 1. Okay, so Kali Linux was here, and it was directly connected to that network. Today, I will deploy the FortiGate next generation firewall. So we're going to deploy it. And then we will configure or will connect the Kali Linux to a new virtual network called VMnet 3 with these public IPs. Even if I'm using the public IPs, it's just to simulate internet. Okay, everything is inside my physical PC. But to make it more like realistic, I will be using this public IP from the Algerian IP space. Then I will connect my Kali Linux to this VMnet. So I will configure it with an IP like 41.201.196.20. And my firewall will get the same subnet but the .255. Then the firewall will connect to the WAF through the VMnet 1. So guys, if you already deployed the topology from the previous session, this part has not changed. Everything is exactly the same. The policy is configured, the VS is the same, the web application is the same. And even before we start, I will just show you the access from the Kali Linux to the backend. I didn't make any change. My topology, so let me show you that. Okay, so my topology, which is here, it's using exactly the same connection as we did last time. So if I access my Kali Linux, you see, if I just Control F5, remember whenever you're testing, use Control F5 to refresh to avoid using the Firefox cache. Okay, so I can access my backend servers. You see, I'm load balancing between server 1 and server 2. Now, if I take a look on the connectivity, you see that my Kali Linux is connected on the VMnet 1. And that's exactly from the previous session topology. Let me show you that for those who didn't attend. So this is exactly the topology from the last session. Okay, so what we are about to do is to deploy a firewall. The firewall will connect to that VMnet 1. The Kali Linux is just connected to a new VMnet called VMnet 3. Okay, so let's start doing that. Again, what I recommend you just to watch me do the demo. Okay, after that, you will get access to the recording. You can deploy your own architecture, and then you can test by yourself. Okay, just by following the video. So let me start by deploying the firewall. So here is my firewall file. I will just open the OWASP file, accept the license. I will name it just firewall. Okay. Perfect. So it's deployed, just powered it on. Okay, first thing, I will change the connectivity. I will move from this topology to that topology. So first, I will go to my firewall. I will connect the port 1 to the VMnet 3. I'll connect the Kali Linux to the VMnet 3 also. So I'll go to my Kali Linux. Let me start with the Kali. Connected to the VMnet 3. Perfect. I go to my firewall. So the port 1 is facing the internet, which is in reality behind VMnet 3. And port 2 is facing VMnet 1. Perfect. So by doing this, I have connected my WAF to these two different networks. Perfect. Oh, where is my PowerPoint? So here you can see the firewall, port 2, firewall, port 1. Again, my firewall is just a new VM. It has no IPs. It has no routing, so nothing inside. I will configure everything during the demo. Okay, where is my workstation? Perfect. So the firewall is just initializing. Sorry. So I will go to my Kali Linux, and first I will change its IP address. So which IP should I use? I don't know why, but my Kali Linux has a bug. I cannot access the network configuration from this. So I have to say network, advanced network configuration, wired connection 1. And I will change it to, let me check again. It's 41.201.196. 201.196. Oh, sorry, 196. And I will put 20. The gateway, in my case, is the firewall that's going to use 41.201.196.254. This is the IP of the, oh, sorry, it's not 14, 41. Perfect. Now I'll just save. So to take effect, I have just to disable the network interface card, enable it again. Let me check if the configuration has been accepted. If config, perfect. You see? Let me double check also the IP. It's correct. Now, if I try to ping the firewall, it will not work. Why? Because the firewall is just not configured yet. 41.1.1.254, not working. Okay, my firewall, yes, my firewall is ready to use. Remember, exactly like the WAF, admin without a password. And then it's asking me to change the password. I changed the password. Now I will just use the same configuration that we used with the WAF to configure the firewall interfaces. So again, I will put the port 1 here in the 41.201.196.254 and 10.1.1.254 in port 2. So let's do it together. Config system interface, edit port 1. By default, the FortiGate has a DHCP client enabled in port 1. So to configure it as a static IP, I should start with set mod static, then set IP 41.201.196.254/24. Set allow access, HTTP, oh no. In the real life, the interface facing the internet should have no administrative access. Just for troubleshooting, you can enable, for example, ping. No HTTP firewall administration should be allowed. Then I can say next to move to the next port, edit port 2. Same thing, set IP 10.1.1.254/24. Set allow access, HTTP, that's also used for management. HTTPS, SSH, and ping. I can say end, and I can just verify my configuration using the get system interface. Use the shift page up. You can see port 1 has the 41 IP address. Perfect. So I can use now my graphical user interface using my Firefox to access the firewall GUI. So let me open my Firefox. So first I will access the WAF 10.1.1.1. You see, this is the FortiWeb from, yes, it's connected. I tested the WAF before the session. This is why it doesn't require an authentication, okay? I open then the 10.1.1.254, and this is the firewall. I will use the admin and the password I just configured. And here I'm connected to my firewall GUI. Perfect. Don't show this again. You can see that the GUIs are pretty similar. Always the sections are on the left, and then the main area to configure things is in the right. Almost the same logic. Now, inside the firewall, what are the basic configurations I have to do? In the firewall, I will just start by, showing you the IP addresses I have. Now, let me ask a question for people with a networking background. I want my firewall to forward traffic to the WAF, and it will receive traffic from the internet. When the WAF receives traffic, it replies, of course, after checking with the backend, it replies to the firewall, and the firewall replies back to the client. So the firewall is just a gateway. Now, let me ask you a question, guys. I configured the IP on port 2, and I configured the IP on port 1. Should I, in that specific situation, configure routing in the firewall or not? Is the routing mandatory in that specific situation or not? What do you think? So guys, from the lab perspective, no need to configure routing. Why? Because the internet is just a subnet directly attached to the client and directly attached to the firewall. So the firewall is directly connected to the client, so it has a ready-to-use connected route. So there is a connected route to the network 41.201.196.0. And it's exactly the same thing for the 10.1.1.0. It has a connected route to the 10.1.1.0/24. The first one is via the port 1. The second one is through port 2. But in the real life, you will never find this situation, guys. The firewall is never connected directly to the client. Instead, the firewall is connected to the internet service provider that represents the default gateway of the firewall itself. This is why it's not really required in the lab, but I will do it. I will configure a static default route to teach the firewall how to reach the internet. So the route will just include the 000/0 subnet, and it will be via the port 1. Why? Because internet is behind port 1. So that's the only configuration I will do after showing you the IP addresses. So in the firewall, if I go to network interfaces, you can see the 2 IP addresses that I configured on the GUI. Of course, you see that the HTTP is in a green color, so in a red color. Why? Because you should never use it in production environment. Use only HTTPS. Okay, someone with some hacking skills can just eavesdrop your access to the firewall and can see just your credentials. So these are the interfaces. If I try to go to static route, no static route have been added. I just create a new one to say 000/0. It's behind port 1. Only this. Now, if I want to check the routing table of the firewall, I can use the get router info routing table all. And I know that many people have studied the CCNA. This command is the equivalent of the Cisco command show IP route. So here you can see my 3 routes, the 2 connected. I didn't configure them. They are inherited from the interface configuration. And this is my static route, the one I just added. Now, when I do this, my firewall is ready to be used. Now, let me ask you a question. What if, remember, the new topology is exactly like this. Now, the Kali is connected to the firewall is connected to the WAF. If I go to the Kali Linux and I try to ping exactly the same gateway, should it work? Oh, sorry. I configured. Oh, why I did? Yes, it was 41.1.1. It was just to show you the example. In reality, it's 41.201.196.254. Is this supposed to work? And the answer is yes. This is the proof that my topology is connected correctly. Kali is able to ping the firewall. If I go back to the firewall, I can open its CLI from here. I can ping the WAF, which is the 10.1.1.1. For Fortinet, you have to add execute ping. You see, the ping is working. And of course, the WAF can ping the backend servers. It was tested in the previous session, but let me just do it for learning reasons. So 172.16.1.101. You see that the WAF is able to ping the backend server 1. Same thing for the backend server 2. So I just showed you that my topology is connected and it's built correctly. The ping here was successful. The ping here was successful. And these 2 pings were also successful. Now, let me ask you another question. What if, without configuring anything additional in the firewall, I will try to access the VS. I will try to access the virtual server in the WAF. So I will just open the browser and use the 10.1.1.100. Is that supposed to work or not? Who can tell me? If I just try to open my, where is Kali Linux? Again, I open the browser and I will try the same thing. Tawfiq is saying, Fuad is saying no. Let's try. Control F5. You see, it's trying again, to show you that it's not working. Let me open a new tab. Copy just IP. Paste it. And you see that the access is blocked. Now, why? Simply because every single firewall that I know, okay, I've worked with many vendors during my journey. Almost all the firewalls apply what we call the whitelisting logic. So what is the whitelisting logic? The whitelisting. It means that Fuad is saying, yes. Fuad is saying that it's an implicit deny policy. Every firewall is with the logic to say what is not implicitly allowed. If I don't configure any allowed session or policy, everything will be blocked. So every firewall you deploy is having just what we call a deny all policy. Nothing is able to go through the firewall. Now, if I go to my firewall, let me show you this, what we call the implicit deny. If I go to my firewall and I go to my firewall policies, go to policy and object, firewall policy, you can clearly see that I have a default one called the implicit. You see, it's implicit deny anything, which is all. The destination IP can be all. The schedule always means 24/7. Whatever the service, whatever the interface is, the action is to deny or to block. And you can see that this policy is now blocking 10 kilobytes of traffic. This is the traffic I'm trying to initiate. If I try again, okay, you can clearly see this counter increasing. So I'll go quickly to my Kali Linux and I try again. Control F5, Control F5. I go back to my WAF or my firewall. You can see here the counter increasing. You see, 14. Now, guys, remember from the explanation, what are we supposed to configure in order to have my Kali Linux access my web application? So Tawfiq is saying rules to external plus NAT, DNAT from external to internal plus policy. And that's exactly that. So guys, what are we about to do now? Let me display the topology again. First, remember that in the real life, people can never reach the destination 10.1.100. This is the VS inside the WAF. Why? Because the internet is designed to never accept private IP addresses. So forget about it. You have to configure a public IP. Now, which IP address are we supposed to use? In the real life, whenever you get internet access, for example, this is Algeria Telecom, they provide you with an IP address that you can use in the device port, but most of the time they provide you with with other IP addresses. For example, when you pay for your internet access, the internet service provider tells you that you can use the 41.201.196.254. That's your IP. You can use the same .100. For example, for some enterprises, they pay for a professional internet access. They can get more than 4 IP addresses. So in my situation, I am the owner of this IP, and I'm also the owner of this IP. So I will use one of them. I prefer to use the dedicated one, which is 100, to configure a destination NAT. Again, the role of the destination NAT is when people are trying to access the 41.201.196.100, whoever tries to access this destination IP, it reaches out to the firewall. The firewall replaces that with an internal IP. So I want the public IP to be replaced with the VS private IP, which is the 10.1.100. Okay, that's called the DNAT. Now, the FortiGate has a very simple way to configure DNAT. And this is specific to Fortinet. Okay, if you go, for example, to a Palo Alto, to a Huawei firewall, the configuration is pretty different. The logic, the concept is exactly the same, but the configuration is different. Now, in Fortinet, to configure a destination NAT, you have to configure what we call a virtual IP, a VIP. The virtual IP is an object with a public IP and its mapped private IP. So it's just an object that I will create. I will provide a name. It takes a public IP and translate it to a private one. Then you have to take the virtual IP and you have to use it in a firewall policy. So I will configure a VIP. I will configure a firewall policy. The policy must allow traffic from port 1. This is what we call the incoming interface, the interface receiving the traffic, to port 2, which is the outgoing interface, because the traffic will exit from port 2, and it from all IP addresses, because the internet means all IPs. I don't really know the IP of my client. It can be from anywhere in the world, but the destination IP is the virtual IP I created. So just by creating the VIP, putting it inside a firewall policy, that will allow DNAT plus allowing the traffic. Okay, so one configuration will allow the traffic and NAT it. So how can we do that? Let me show you. I will go to my firewall. First and foremost, I go to policy and objects, and here you can see firewall IPs. Oh, virtual IPs, sorry. I have no VIP configured yet. I just say create new virtual IP. I will call it free shop virtual IP. Okay, let me just take this. I will use it many times. Now, what is the external IP range? What is the IP that people are using to reach my web application? It's 41.201.196.100. Now, this IP should be mapped to 10.1.1.100. And that's all. By configuring the name, the public and the private IPs, you have configured your VIP. Now, the VIP is then used inside a firewall policy. Now, to configure the firewall policy, I will add a policy that will automatically be put on top of the implicit deny. The implicit deny is a rule that is always at the end of the list. Now, create new policy. I will call it free shop firewall policy. Or I can call it, I prefer to say access policy. Now, what is the incoming interface? Traffic is arriving at port 1, facing the internet. It will go to the WAF through port 2, facing the WAF. The source, again, is all. All IP can access my WAF, my application. What is the destination? At the end of the list, you can find virtual IPs, free shop IP. This is exactly the one I configured. Now, which services people can use to reach out to my backend application? Can they do, for example, ping? Can people ping my web servers? I should say no. We always configure firewalls and keep in mind the least privilege concept. If people are supposed to use HTTP and HTTPS, you should only allow HTTP and HTTPS. You should never allow FTP, never allow SSH. Okay, by saying HTTP and HTTPS services, people can only use their browsers to access my web applications. Now, what is the action? By default, we configured this to accept, to permit. Then, should we use the source NAT? Guys, when we configured the virtual IP, it was about the destination NAT. And the destination NAT is used whenever you want people to access your internal resources. The source NAT, in the other hand, is used by organizations to allow their users from the internet network as clients to access internet websites. In my case, I should disable source NAT. Now, to avoid any misunderstanding, guys, in FortiGate, this NAT means source NAT. Using a VIP means a DNAT. So inside the policy, this configuration triggers a DNAT, and this configuration triggers a source NAT. Since I don't need the source NAT, I just disable it. Okay, so no NAT, I can apply antivirus, I can apply application control, intrusion prevention system, but remember, I'm using my firewall just for NAT and policies. Now at the end, I would prefer to say log allowed traffic, so I can see in the logs all the sessions that are created on the firewall, and I just say okay. Okay, I would prefer to change also the time zone. Why? Because when I will be seeing the logs, I would prefer to see something similar to my time zone. Okay, now I'm in Algeria. The time zone is the West Central Africa. Perfect. Now my firewall is configured with the firewall policy that is inside it triggering the destination NAT. Now it's time to test. Okay, I can go now to my Kali Linux and I can, now am I supposed to use the 10.1.100? What do you think, guys? Am I supposed to use the 10.1.1 to test access? Abdelrazak is saying use, yes, the public IP. Guys, remember, the goal is to use the public IP. This is not valid on the internet. So 41.201.196.100. And here you can see that I'm able to access the backend server. Now, guys, what happened exactly? Let's try to recap from the visual perspective. I have used the 41XX100. This is pointing to a virtual IP in the firewall. The virtual IP triggers a translation to the 10.1.100. And the virtual IP access is allowed inside the policy. So the firewall simply allows the traffic, translate the destination IP to the 10.1.100. Then it forwards it to the WAF. Inside the WAF, we did it in the last session. There is a virtual server listening on that specific IP. And then the VS passes to the web protection profile. Then it's forwarded to one of the backend servers. And that's exactly what happened. If I try to refresh, I can clearly see the load balancing using the round robin algorithm. So if I open again, I just say Control F5. Okay, what? It seems like something is blocked. Maybe the WAF blocked something. Let me try again. Okay, let me check the logs. For example, if I go to my firewall, I can go to my logs inside the firewall first. I go to forward traffic and I can see traffic from this source going to that destination. And you can see clearly that the firewall has allowed this using this green mark. So the traffic is allowed. Now, if I go to the WAF, I will try to check if there is any attack. I should find nothing. Okay. Maybe I'll find logs from previous sessions or when I was just preparing the pod. Yes, you can see nothing is from the 41, nothing from, any attack was launched. If I go back to my Kali Linux, I don't know why it's locked. I can expect a performance issue. 201. Let me check my servers. Everything seems okay. Guys, if I go to my WAF, I can use, for example, the dashboard, view topology, and here I can see if the backend servers are reachable. And here you see the green mark, this arrow, it means that the two backend servers are reachable from the WAF. I can test them. It's direct access to the web applications. First one is available.
If the reply in FortiGate is 0.
Reply in FortiGate is 0.
Yes, when you see the traffic result.
Yes, but what is causing that? You know, when I accessed, I have seen the application, or I have seen the web page. Okay, let me try to do something. And this is what we're going to need in the next demo. By default, the FortiWeb doesn't keep access logs. If you say attack, it keeps track of attack-related logs, but not traffic logs. So you hold on a second. Let me check the configuration. Maybe it was from the test. The FortiWeb by default has the traffic logging disabled. So let me check config log. You see, you can configure the attack logging and yes, traffic log. Inside this, I can say show full configuration, and you see that the status is disabled. Why I can see these logs? Because I've tested that before the session to prepare the lab topology. Okay, these are old logs. If I go and say set status enable, the FortiWeb starts generating traffic logs. Now, what is a traffic log? It's a log describing which IP access to which backend server. Even if there is no security incident or no security event, the WAF keeps track of the traffic logs. In the real life, that's not a very good idea. Why? Because if you are enabling logging in your firewalls, the firewall should be able to give you all the details about the sessions. And if you do that on the WAF, you can use the WAF disk in a very short period. So let me just say, and I have enabled logging for traffic logs. Now, when you do that, you can go to the server policy. Remember the server policy we configured in the last session? So here you see the name, you see the VS, the real backend servers. And here you see a new option when you enable it globally, enable traffic log. I can just enable it like this. And whenever I try now to access anything, I should see traffic log being generated. So let me go to my Kali Linux again. That's really weird. Let me try to access again. I will see what is going on the WAF traffic logs. Hold on a second. Okay, is it? I have to check the time. 27. What's the time on the system? Let me check the time on the system. Where's the time? Yes. 22. Oh, so these are still old logs. Okay, it seems that no traffic is being forwarded by the firewall. Let me try again. That was not expected. Okay, let me try to troubleshoot the issue. Show matching logs. I can see traffic generated from the firewall. Here you can see the IP address of the source, which is Kali Linux. This is the IP address of the destination, and it was denatted. You see here the natted IP, and you see the port. Okay, traffic is being sent to the WAF. Let me try to sniff. I can use the TCP dump-like command in the FortiWeb. I can use execute or diagnose network sniffer on port 1. And I want to see only a host 10.1.100 and TCP and port 80. I want to see traffic. Okay, arriving to port 1 from that. Okay, this is, you see here we can see that the client, Kali Linux, is sending a SYN. It seems that Firefox is trying to refresh. You see, Firefox is trying to refresh the session. Now here we can see that the FortiWeb receives. Now let me check if the traffic is being forwarded to the backend servers. How am I supposed to do that? Oh, come on. I can just make the same thing, diagnose network sniffer. And I say port 2 facing the backend servers. Same thing, I will say host 172.16.1.101 or host 172.16.1.0. Come on, I cannot. Excuse me, I will. Okay, I'll start over. Diagnose network.
Mehdi,
Yes,
I don't know, but I have a proposition. Should we
yes, sure.
configure a second policy to allow outgoing traffic in second direction in
No,
the
no, no.
FortiGate?
No. The FortiGate is the stateful firewall. So you just have to enable or allow traffic in one direction, and it will automatically allow traffic in the other direction.
Okay.
Got it?
Okay. I got it.
I will say TCP port. Oh, no, sorry. TCP and port 80 and host 16.1. Like, come on. Like, it seems that there is something wrong with the
I think
the
it's a
CL.
bug.
Yes, in the GUI. I will just open PuTTY.
Yeah.
No problem. So I will just open to access my WAF like this.
I'm sorry. Can you activate the ping to test just the return of data from firewall?
What do you
You
mean?
create now HTTPS. You
Yes.
can open the port for just ping to see from external if you can reach the your server in internal, and you see if traffic.
Sorry. Sorry.
I'm sorry.
No, it's me. I'm really sorry, guys. I just forgot one step. Oh my God. Guys, okay, without testing, let me ask you a question. Okay? When I'm trying to access, okay, the traffic, I check that the traffic is received by the WAF. When I run the diagnose network sniffer, you can see the SYN coming from the 41 client, but there is no reply. Guys, I didn't configure any routing.
Yes, that's why I say in first we have result 0. We have just
Exactly.
in, out. Yes,
So
that's
what
they
is
say.
happening is that the WAF is receiving traffic. The WAF is sending or can send to the backend, but there is no valid route to the 41. So the WAF is just dropping packets because of a routing mismatch or route not found. There is a routing issue. So I believe just by configuring the route, sorry, something I forgot. I was just concentrated on the firewall. I forgot to tell you that we have to configure a route in the WAF. So I will go just to my WAF network route, and I have to teach my WAF how to reach the internet. So 000, in my case, it's behind the firewall with the IP 10.1.254, and it's behind port 1. When I do that, I have defined inside my WAF how the internet is reachable. So I believe that now the test works. You know what's really weird? Why did it work the first time? That's really weird. I believe maybe I didn't use the control F5 correctly. Maybe it was cached on the Firefox cache. Now it's working. You see? Just by adding the default route on the WAF, now it's working. Again, if I just control F5, you see, load balancing is working between server 1 and server 2. Now, guys, again, let me check the logs very quickly. I go to my firewall. I will go to my log, traffic log. You see, traffic is coming from Kali. It's forwarded, or the destination is the virtual IP on the firewall. If I double click, you see that the virtual IP is doing the DNAT from that public to that private. I go now to my WAF. If I go to, log and report, log access. If I go to my traffic, now you see new time. The IP from 41.20, which is Kali Linux, has made it to the server 2. Here it made it to the server 1. If I just double click, you can see the traffic details. If you go to attack logs, there is no attack related to this. Why? Because I didn't try any attack. If I just want to trigger something, I can just go to DEM vulnerable web application, and I will just put, or 1 equals 1 just to simulate something. You see, it's blocked my WAF. Remember the last session we configured the WAF to block these SQL injections. If I go back now to my attack logs, I'm supposed to see some, yes. Here you see it's severe threat level coming from that client, Kali Linux. You see it's the subtype is SQL injection. If I double click, you can see all the details about the attack. So guys, we have just added the firewall in the middle to add its DNAT capabilities and the firewall capabilities. Do you have any question? Any question, guys? No questions?
In case if we activate in firewall
Yes.
the filtering web, the
Yes.
firewall he can capture the packet of injection of SQL or not?
No. Why? That's a good question. Guys, in the firewall, when you are talking about web filtering, it's to protect your internal users. If you have someone trying to access, for example, to Facebook, or trying to access to a hacking website or any phishing URL, the web filter is used to protect clients. It's not used to protect web applications. So you cannot use it to protect your backend applications. If you want to do it, there is a small WAF feature inside FortiGate. That WAF capability is used to protect backend servers. But since we have a FortiWeb, so no need to enable that. Okay? Make sense?
Yes, sir.
Perfect. So guys, I think it's time to take a short break.
Yep, Mehdi, no problem. For
Okay,
10
so let's
minutes?
take, yes, 10 minutes break.
Okay.
Try to, drink something, try to re-energize, and then we'll start the next part, which is the X forwarded for. So
Okay,
see you in
no
10 minutes, inshallah. Thank you.
Yeah, no problem. Thank you.
Hello, everyone.
Hello.
Okay, so we have a question from Tufir. Tufir, can you go ahead, please?
Yes. Yes, please. In the case of the mailing server like Exchange, we can configure the WAF with him or not. Also with application ERP, like SAP or like other application.
Okay, I got the question. So whenever you have a web access to any kind of service, you can use the WAF to protect it. For example, you're talking about the SAP. As far as I know, the SAP main access is using the web. So employees access through a web portal. So of course, yes, you can, like, this is your SAP. You redirect your traffic to the WAF to the WAF to protect it. Why? Because it's using web access. Now, for the email system, you said, for example, Microsoft Exchange. So this is a bit special. Why? Because to access your emails that are hosted in your Exchange server, there is two ways to do it. As a user, you can use what we call the OWA, the Outlook Web Access. This is purely HTTP. This is a web access. And this OWA access can be secured using FortiWeb or any other WAF. But if you are using SMTP, and this is most of the time the case when you are receiving emails as what we call in the organization the inbound email, the SMTP traffic cannot be secured using a WAF. So the goal here is to inspect SMTP, and this is where we use what we call the SMTP gateways or the email gateways. So in maybe 90% of Exchange deployment, you find organizations secure its inbound email for SMTP using a dedicated email gateway, such as the Barracuda anti-spam gateway, the Symantec, the FortiMail, the Cisco IronPort email. And the OWA is an ActiveSync, by the way, for mobile devices. They are protected using the WAF. So the answer is yes and no in the same time. Yes,
Thank you.
you're welcome. Someone is saying, please don't forget the two questions of the last time. Can you just be more precise, please? You mean the questions from the session 1? Oh, good. Yes, one of them will be answered in great details. And this is what we're going to do in the X forwarded for. The other question, if you remember, I asked about the asymmetric traffic. I will just give you a brief answer to the question. Okay, just bear with me. So guys, the next concept here is the X forwarded for. And why do we need it in WAF deployment? So let me give you a scenario. Imagine that your web application is developed in a way that uses the user location to provide specific content. For example, if the client is coming from Algeria, I wanted to get Arabic traffic or Arabic content. If the user is coming from, for example, India, like the last time, we want the traffic to be in Hindi or English. Imagine that you want your web application to restrict some access or access to some traffic based on your source IP. So imagine that the back-end application servers, they are configured with some anti-bot capabilities. So they need to see the IP addresses of your real clients so they can block them based on their public IP addresses. Now, in this situation, don't forget that your backend servers are protected with a WAF. The WAF itself is behind the firewall. Now, when the client accesses the firewall, sometimes the access is forwarded directly and the WAF is able to see the source IP of the real client. And this is exactly what we tested. When we accessed the logs of the 40 web, we could see the 41.x.x.20. So the WAF is aware about the source IP of the client. Now, since the WAF is deployed in the reverse proxy mode, remember what we have said from the beginning. We said that in reverse proxy, the key point is that the first IP connection is using the client as a source and the WAF as destination. And for the WAF to reach out to the backend application, the WAF uses a completely independent IP connection, which means that the first IP connection that I'm representing with this green arrow is completely different from the one I'm now representing using this yellow arrow. And here the source is the WAF, the destination is the backend. So with this reverse proxy deployment, the backend server is prevented from checking the real IP address of the client. So from the backend application, all the traffic coming from the WAF is seen from the source IP of the WAF. So no content like policies can be applied. I cannot see the real IP of that guy, 41.1.1.1. So I can detect that he's from Algeria. I cannot see the IP like 4.1 or 3.1.1, and I can detect that it's from India. I'm just preventing the backend server from knowing the real IP address. Now, what is the solution to that? In reality, there is two solutions. One of them is not recommended. The other is the recommended one. So let me get back to the topology to explain these two solutions. The first one is to use what we call use the client real IP inside your policy configuration. And that's a feature present in the 40 web and other WAF vendors. When you use this feature, you are instructing the WAF whenever it receives a connection from a client. So the source is the 41.x.x.20. And whenever it tries to reach out to the backend, even if it's a different IP connection, it will keep the same source. In reality, the WAF is just spoofing the source IP and using the real client IP. So you're just modifying the behavior of the reverse proxy deployment mode, because the basics of the reverse proxy is to use a new IP connection. Now, this can be a solution, but this can lead to asymmetric routing. Again, this will be the answer to the question I asked in the previous session. If you do that, don't forget that the backend servers in real life are always connected to an out-of-band management network. This out-of-band management network is itself connected to the internet through, most of the time, through the firewall itself. So the out-of-band management is connected to the firewall. So whenever a backend server wants to do, for example, an operating system update, it reaches out the internet through its out-of-band management network. So in this situation, the backend server has two different ways to reach the internet. One is through the WAF, and this is not possible. Why? Because remember, the WAF is here just to inspect HTTP traffic. So if you try to ping, if you try to download something, if it's not using HTTP, the backend server cannot reach the internet like this. Instead, the WAF the backend server will simply use its out-of-band management. So what's the problem with that? So let me remove all the details. Just keep this. This is my out-of-band management network. Let's take this second server as an example. Inside the server, guys, you have to configure a single gateway. This is just a server. The gateway in this example to reach the internet should be an IP address from the management out-of-band network. So the gateway can be like something in the 192.168.1.0/24. So the gateway must be part of the out-of-band management, which means whenever the server wants to reach the internet, it will go this way. Perfect. Now remember, whenever the client is accessing your web application, if you keep the reverse proxy deployment by default, the source IP used to reach the server will be the WAF, like the 172.16.1.1, which is that specific IP. When the server is receiving traffic from the source IP, the server will directly reply to the WAF. Why? Because they are in the same subnet. The server is directly connected to that subnet, so it will never use its gateway to reach out the 172.16.1.1. And this is why this is the default behavior of the WAF. By default, it's like this to avoid what I called the asymmetric routing. So to tackle the issue that we explained previously, I mean to provide the real IP address of the client to the backend application. You don't want the application to see the WAF. You just go to the WAF and enable the use the real client IP. When you do that, the WAF will replace its own IP with the real client IP, like the 41.1.1.20. But what will happen is the following. The traffic is received on this interface, but how is the backend server supposed to reach the internet? Since the 41.1.1.20 is part of the internet, the backend server will use its gateway to reach out or to reply to the client. And this is by default will be blocked by all the firewalls. Firewalls never allow traffic to be received from one pair of interfaces, like the traffic previously was received from port 1, it was sent out to port 2. How is that possible now to receive the traffic from port 3? This is what we call asymmetric routing, because the traffic is going from one path, but the reply traffic is received from another path. The firewall here will just drop the traffic. You can also fix that by configuring the firewall to be a stateless firewall, but this is never a recommendation, and I'm not going into the details. Okay, so the solution I'm giving you is that the firewall can be configured as an stateless firewall, so it can allow asymmetric traffic, but this is not a good solution. Now, guys, how are we now supposed to fix the issue without configuring this use real IP client? And the answer to this is to use the X forwarded for header. So what is the X forwarded for header? Let's simulate another access from the client to the backend server. So this guy here said HTTP : 41.x.x.100. And this is a virtual IP on the firewall. So the traffic is going to the VIP. The VIP removes the 41 IP, replaces it with the 10.1.1.100. So here the destination is 10.1.1.100. But what is the source? The source is the real IP, okay? Because we didn't configure any source NAT or something like that. So it's 41xx20. Now, when it arrives to the WAF, I want to keep the behavior of the WAF exactly by default. So the WAF initiate a new IP connection, and the source will be the 172.16.1.1, which is its own IP. and the destination will be one of the backend servers, 172.16.1.101. Now, I can instruct my WAF to add a specific HTTP header. For people who don't know what is an HTTP header, it's a piece of information that the HTTP packet can include. So this added HTTP header is called the X forwarded dash 4, and it includes the real IP address of the client. In my case, this 41XX20 is the real IP of the client, so the WAF knows it and it will include it inside the HTTP traffic at layer 7. Now guys, this X forwarded 4 is at layer 7. It's part of the HTTP traffic. It's inside a layer 3 IP packet that uses the source IP, the 172.16.1.1. So the source IP at layer 3 is the WAF, but the source IP at layer 7 is the real client. And this is what we call the X forwarded 4. So guys, that's the logic. Remember the following. If I want to summarize this, whenever you want to use X forward 4, it means that you want to send the real client IP inside HTTP. Why? Because you lost it at the IP level. That's the goal. Now, what I explained represent in reality one use case. It's when the backend application wants to see that. Now, what if inside the firewall you enable the source NAT? Or what if behind the WAF you are using a load balancer? For example, imagine that you put a load balancer here, and most load balancers, they use the reverse proxy deployment. It means in the previous use case, the IP was hidden from the backend server, but if I use a load balancer with the reverse proxy, the WAF itself will not be able to see the IP address. So in some situations, you have to configure the device in front of the WAF, the load balancer, to use the X forward 4 header to pass the information to the WAF. So in a real production environment, you may configure the device in front of the WAF to add X forward 4, or the WAF to add it to the backend. So it depends in the situation. Sometimes you have to configure it twice. So the load balancer passes the X forwarded 4 to the WAF. The WAF reads it and encapsulates it or add it again to the HTTP to see or to help the backend application. So we can have two X forwarded 4 configurations to read it and then to insert it for the backend. Guys, is it clear? Can you see why do we need that? Can you see the issue?
Mehdi,
Yes.
I have a question. I
Sure.
understand what you said. I have a question about the zones of the firewall. For example, we know that there is three main zones. For example, the inside, the outside, and DMZ. In this architecture, I think it's the most used in production environments. But we didn't talk about the DMZ. Maybe it's coming in the future. In the future slide.
Not really. I didn't plan to do it, but we can have an explanation about that. So let me do it right now.
Okay.
So in general, and that's part of the firewalling. Okay, it's not really a core concept when you're talking about WAFs. But when you are talking about firewalls, whenever you say firewall, it means isolation. It means that you have different areas with different security requirements, and you want them to be isolated. When I say isolation, it doesn't mean 100% isolation. It means I isolate, then I apply access control in a strict way. In firewalls, in most deployments, you find at least 3 different areas or 3 different zones, like you said. The first zone is the zone that you don't really trust. Most of the time, it's internet. Some vendors prefer to call it the outside zone or area. Some vendors prefer to call it the external zone. It's whatever. The outside means that you don't trust at all. In the other hand, you have your, for example, data center. This is your DC, hosting your own controlled applications. So the data center is something that you trust because you are the owner. You know exactly which applications are running. You know the IPs, you know the tools, you know everything. This is called by some vendors the inside network, and some other call it the internal network. Now, if you put a firewall, the firewall will always isolate the 2 areas or the 2 zones. So whenever you have traffic trying to flow between them, it will be controlled by the firewall. For example, if I know that no one from the internet is supposed to access my data center, imagine that you have internal users. These are employees. These employees are the only people who can access the data center. In this case, you configure a firewall policy to deny any protocol from the internet to the data center. So everything is blocked. But when the traffic is initiated from the data center to the internet, for example, your data center applications want to do updates, they want to, I don't know, download something, you can allow specific traffic like HTTP and FTP. So with this topology, here you have no trust at all, and here you have full trust. Now, what if you want to make a specific application reachable from the internet? I mean, what if inside my data center, I have a Microsoft Exchange? Like the example you mentioned before, or Tufik mentioned before, you have Microsoft Exchange. And the Microsoft Exchange should receive emails from the outside. What if you will go to the firewall and you allow from the internet to the data center the HTTP traffic for webmail plus the SMTP traffic? Can you tell me if this is a good idea? Who can tell me? Why?
Because we have a risk.
What is the risk?
The server is exposed for the internet. We don't have it's not isolated from data center.
And exactly this is the answer. Why? Guys, when you open something to be available on the internet, imagine that it's not your fault, but there is a new 0-day CVE exploited on the latest version of Microsoft Exchange. This is not really your fault, okay? This is a CVE that we have just discovered on Microsoft Exchange. So someone maybe will use the HTTP traffic or SMTP that you opened to take control of your server. So your server is now compromised. The server can be used as what we call a pivoting host. From that server, which maybe the hacker has an SSH access or, I don't know, a full access, he can do the pivoting or what we call lateral movement. So he can go to your other services. He can reach out your DNS server. Maybe he can access your Active Directory. So you cannot allow the risk of having these pivoting capabilities. So what are we supposed to do? if I want to make something publicly available, I have to put it in a dedicated zone. So I say, okay, my exchange can be compromised. I take the risk. So I will take my exchange and I will connect it to a dedicated area. It's a completely isolated network. Now, everything that should be publicly available should be put in this area that vendors most of the time call the DMZ, the demilitarized zone. So what is a DMZ by definition? It's a network that can at any given time be compromised. So I have to allow people to access my DMZ, but if the guy takes over my server, he can control it. There is no direct access to my data center. So even if I open HTTP and SMTP, there is no access from the DMZ to the data center. Okay? Make sense?
Yes, I got you, Mehdi. Thank you.
You're
For
welcome.
now, since we have this architecture, you
Yes, yes. No
okay,
problem. Yes.
since we have this architecture, so the WAF is we can put it between the firewall and the servers in the DMZ side.
Exactly.
I
Now,
think this is the best architecture in the production environment. So the WAF
exactly.
exactly will be putted in the DMZ phase and the DMZ side.
That's exactly the case. Why? Because the WAF must be publicly available. So you put your WAF in your DMZ. Okay. This is part of the DMZ. Now, the difference that you may find between organizations is the following. Some organizations, they prefer to put the back-end web servers in the data center like this. So when you try to access the application, you are going to the firewall. The firewall allows you to go to the DMZ. Then the WAF takes the traffic and send it back to the data center. This is using the one-arm deployment. Some other organizations, they prefer this. They open a connection between the WAF and the data center. So the WAF is simultaneously connected to the DMZ and connected to the data center. Now here we have a risk. If the WAF is being compromised, the WAF itself, your data center is exposed. Make sense?
Yep. Yeah, exactly.
And if we want to take, we want to have better security, you can do this, but you can use a dedicated data center firewall. So you have what we call an edge firewall. This is just connecting your organization to the internet, and you add another firewall. The WAF is connected to this firewall, and the firewall is connected to the data center. So even if your WAF is getting compromised, you still have another firewall blocking malicious traffic from the WAF to the backend server. Okay?
You can say like dispatcher or not.
Sorry, can you repeat?
We can say the WAF in this case like dispatcher or not.
What do you mean by the WAF is?
Dispatcher, like server dispatcher or not. Dispatch the traffic from firewall from external firewall to internal firewall.
Not really, because it's a proxy. Traffic is received like this and then sent or forwarded to the data center. And in both cases, we're going through firewalls. Okay, and this is what you find in most, let's say, medium or large organizations. They have always a dedicated firewall, data center firewall, and they do have also an edge firewall. And this is the most secure way to do it.
Thank you, Mehdi.
You're welcome. So guys, again, these are the use cases. Let me just summarize. The first use case to use the X forwarded for is when the web application itself needs to monitor the client real IP. So in this case, you go to the WAF and you configure the WAF to add the X forward for before forwarding to the backend server. Okay, this is the backend server. The other use case is when the WAF itself is behind a load balancer or a proxy. So you have this load balancer or proxy. I can just say you have a NAT device. This is very common when you are deploying proxies and load balancers. This NAT device will receive the traffic with the real IP, but it will use its own IP address to reach the WAF. So the WAF is just blinded. It cannot see the real IP. So you can configure the NAT device to add the X forward for. So the first use case, the WAF is the X forward for writer. And in the second use case, the WAF is the X forward for reader. In some situations, you find it doing both. You receive the X forward for and you forward it to the backend in the same time. And this is exactly what we're going to do in the last demo. So guys, in this demo, we will do the following. So I have two steps that for sure we're going to do. It depends on the questions. It depends maybe if we have a small issue like we had in the first demo. But optionally, if we are fast enough, we can do the two other tasks. The first two tasks simulate or test the first use case. We are testing if the web application sees the real IP, and the answer you will find no. The backend servers will not see the IP. Why? Because I'm using the reverse proxy with the default configuration. And this prevents the backend application to see it, so to use it for monitoring. And then I will configure and test the X forward for to be sent from the WAF to the backend. So this is the first use case that we discussed. If we have time, we will configure and test load balancing on the firewall. So I will not deploy a dedicated load balancer. Okay. First, it will be too much complex, but the FortiGate next generation firewall has inside it load balancing capabilities. So I will configure the firewall as a load balancer. And you will see that when the traffic is arriving from the Kali, the FortiGate starts hiding its IP address. When I do that, I will configure the FortiGate to send the X forward for, and then the FortiWeb WAF will just read it. So I will start with the first use case, and then we'll configure the other use case. So guys, what are the steps? Very easy. First and foremost, I will access my backend server. So guys, to avoid checking the first and second, I will just power off this one. So I don't want to see load balancing. I want just to access to server 1. So I will put all my tests here. And then I can power it off or just remove it from the server pool. Okay? To avoid testing in both servers. When I do that, I will just access again. And I will run a TCP dump on the backend server. You will see that the source IP is the WAF's source IP. And you will see that the HTTP traffic doesn't include the real IP server by default. So it's a lack of monitoring capabilities on the web application. Then I will go to my WAF and I will configure it to add the X forward for. And then we test again. Then we will do the same thing. I will enable load balancing here. It will start doing source NAT. So I will check from the WAF itself, and I will not be able to see the IP addresses. And then I will configure the FortiGate, the firewall, to add the X forwarded for, and I will configure the FortiWeb to read it. So two scenarios, and let's do it now. So I will start on the, I will start on the Kali Linux, and I will just run another test. Kali. Again, you see the access, perfect. Even if I try something dangerous like IT equals, just to test, or 1 equals 1, something like that. Oh, okay, don't really care. Let me try this. I'll try the like this. Okay, I just triggered logs. I will go now to my FortiWeb attack logs. You can clearly see that the source IP will be the real IP configured on the client. You see, 41.201.196.20. Perfect. Let me try this. I don't have a real web application that really needs the IP just to test it. I will do this. I will use TCP dump. Okay, I will just say TCP dump. I want to listen on, I want to listen on interface ETH0. I want to see all the details. And I want to see even the layer 7 traffic. And I want to do it for TCP and port 80. Okay. Perfect. So I will go to my Kali Linux again and try. I will just access. Perfect. Control F5. I go back to my sniffer. I don't know why it's the TCP dump in this Linux PC is very slow. It takes seconds to display. I don't know why. Because usually it's in real time. Yes. Here you can see if I go up here, I can clearly see that traffic. Oh no, this is the response. I will try to take the HTTP request. I will stop just sniffing. Perfect. Yes. So here you can see that the packet what was received at this time. This is the time. And the source IP is 172.16.11. This is the IP of the FortiWeb. And the destination is the backend server. Okay. Yes, I'm using, I forgot to power it off. No problem. I'm on a web server. This is web 2. Here you can see that this is a TCP SYN on port 3W means port 80. Now, if I go to check the layer 7 information, let me just move a little bit down. Here you can see the layer 7 information. In the HTTP request, you see the header called host. This is the what you taped in the URL. This is the user agent. I'm using Mozilla Firefox for Linux because I'm using Kali Linux. You can see the format of the application. It's HTML. And you see many other details. These are what we call HTTP headers. Now, the answer from the backend server, so that was what I just explained is the HTTP request. And from this point, it will be the HTTP response. Let's check it. You clearly see that the traffic was, where is it? Yes, was from the backend server. This is web 2, reply from the server to the WAF. And you see here the headers from the server. And you can see that this is a vulnerability. The server is disclosing sensitive information. All the details about the server, these are the headers, and this is the body. And you can see that the HTTP data or body includes the HTML code. You see here the H2 title, the color, all the details, and you see here the data. Welcome to our web application. Perfect. So what's the, how to call it? What's the output from this test? I can clearly see that it's from the WAF to the backend. The backend application cannot see the real IP at all. So the web developer calls you and asks you to do something. I want to see the real IP address. How to do that? Very easy. Go to the FortiWeb, go to server objects, and you find X forwarded for. You have to configure an X forwarded for policy or rule. Here you can see it. I will just name it. I will name it X forwarded for or XFF. I will call it simple config. Now, I want my FortiWeb to use it or to add it. Remember the first use case, guys. We are here to send it to the backend server. So the goal is to add the X forwarded for. In the second use case, we'll use the use X forwarded for. And these two different options, one is used to add it to send it to the backend. The other is used to read it from the firewall. So I just clicked on add, and that's all. Just enable this feature, just say all. Just say okay. Now, this X forwarded for rule must be used inside the WAF policy. I go to server policy. I have to use it inside the web protection profile, which is used inside the server policy. Remember the last session, we configured the web protection profile. It was the inline extended protection. So I will go to this protection profile. I will add the X forwarded for object that I configured. So I go to server object. Policy, web protection. And here you will notice something specific to Fortinet. If I go to a built-in web protection profile, you don't have the possibility to modify it. It's a read-only profile. The profiles that are built in the FortiWeb cannot be modified. So if I want to add something, I will take the profile I'm interested in and I will clone it. I will call it my free shop web protection profile. So this web protection profile I just created is identical to the inline extended protection. So I will just go inside and I can start modifying. So the only thing I'm interested in is the X forwarded for, and I will call my X forwarded for rule. Just say okay. And everything is done. Now, when I do this, I have to check again. I will just go to my Kali Linux, and in the meantime, I will open my sniffer again, like this. Let me just make some space. I will go back to my Kali Linux, my client. Where is it? Okay, and I will just Control F5. Control F5. Okay, I will go back. Wait a bit. Now, guys, before we see the output, let me ask you a question. What will be the source IP at the layer 3 header? Remember, in the TCP dump, I will see the source and destination IPs. What will be the source and destination IPs? So guys, I got the output. Let me just stop the sniffing. Perfect. So here you can clearly see that the source IP is still the same. Why? Because this is the FortiWeb and this is the backend server. Okay, this is the backend server. This is Web 1. But what you can see, hold on a second. I'm looking for the X forwarded for. Come on, where is it? I cannot see it. Hold on, this is an old capture, maybe. Let me try to find another request. You see here the headers? No. seems that there is something wrong. I will check the latest logs. This is the reply. This is, so it's not, I cannot see the X forwarded for. Okay. Okay, let me check my configuration again. I go to my FortiWeb. Oh my God. Again, sorry. Guys, what's the issue? Who can tell me what's the issue? I have configured the X forwarded for, right? Exactly. Thank you very much, Fuad. The profile I just created, I didn't use it inside the policy. I'm still using the old one. Sorry. So I will go to my server policy. And you see here, I'm still using the inline extended. So I will just use my free shop web protection profile. Perfect. Then I will try again. I go to my, okay, TCP dump, make some space. I go back to my Kali Linux. And I will just control F5. Perfect. I will just wait. I should see the source and destination IPs the same, but I have to see the X forwarded for header in the HTTP layer 7 content. Come on. Okay, I can see. Let me go. Yes, I can see now in this request coming from the WAF. Sorry, I have to stop the capture to avoid this. Okay, so here you can see the WAF. You can see the backend, and you see the X forwarded for containing the real IP of the client. So this can be used by your web application admin to control and monitor who is really accessing your web application. So guys, in a very quick way, if I want to show you the other scenario, it's already 2 hours and 30 minutes, but I will show you how to do it very quickly. First and foremost, I will enable load balancing on the firewall. Oh. To do that, in the FortiGate, you have to change the configuration logic. How? I will go to System, Feature Visibility, and in the FortiGate, you have to enable the load balancing feature. You see, load balance, you have to enable this feature. When you enable this feature, there is a new type of objects that is now available. It's what we call virtual servers. So what is a virtual server? A virtual server is something very similar to a VIP, but it supports more than one private IP. Remember when we configured the virtual IP, we provided one public and one private. With a virtual server, you can configure one public IP with a list of real servers. These real servers are the internal private IPs. And you see, virtual server is a term that is also used in the FortiWeb. Now, what I will do, I will just remove the virtual IP and I will replace it with a virtual server. This virtual server uses the load balancing. Now, if I try in FortiGate to delete a VIP, I cannot. Why? Because the VIP is being used inside a policy. You cannot remove an object that is already used in a policy. I can go to my firewall policy. I will just remove it. I have to replace my virtual shop with another object. Now, in production environment, what if I do this? What if I remove the free shop virtual IP and replace it with all? Guys, that's the worst thing that you can do. If you do that, you have an allowed access to all your internal IPs, which is extremely dangerous. To avoid this, use the object none. The object none is a FortiGate object that never match anything. By choosing the non-object, it somehow you are forcing the firewall to skip the rule. This rule will never match. So I'm sure that no one can access my firewall or my DMZ at all. So in the meantime, I will remove my VIP. So I will just copy this. This is the IP to avoid to tape it. Oh, like this. I will go to my VIP. Now I can delete it. Then I create something very similar. I will call it free shop VS, virtual server in the firewall. It's an HTTP load balancing. This is the virtual server IP. It's listening on port 80. And here you can see that I have the health check. I have multiplexing. I can add the WAF. So guys, even if I enable load balancing, my goal is not really to load balance. My goal is to hide the real IP. This is why I will add just the IP address of the 40 web VS. So what I'm doing right now is configuring a virtual server to enforce the 40 gate to hide the IP. So this is the VS on the 40 web, and this is the IP of the VS on the 40 gate. Now, when you do that, I will go to my firewall policy and I will replace again the non-object with the VS. Now, there is a small detail. I'm not going into the why, but the VS is only available when you choose in FortiGate what we call the proxy inspection mode. Okay, don't ask me why. Okay. Now, when I choose the proxy, now I can select the free shop VS. When I do this, I can, for a reason, configure the FortiGate to do source NAT. Now, when you click on source NAT, the FortiGate can load balance and can hide its or the client IP from the WAF. Now, by doing this, if I try again, or let me just before that summarize quickly, I configured or I removed the VIP and I replaced it by a VS. The VS is listening on the 41XX100 and it's using the 10.1.100 as a real server. So I will point to the same public IP. The FortiGate can forward me to the VS on the 40 web, 10.1.100. Then the 40 web can load balance me using the two real servers. Now, when I enable the source NAT, it means that this IP will be hidden from the 40 web. How am I supposed to check that? I will access from my Kali to my backend applications, and I will check the logs on the 40 web. How to do that? Let me do it again. I will go to my 40 web log. I will just use traffic logs, for example. Okay, I will go to my Kali Linux and I will try again. I will try to trigger a security log. I will just say dbwa. Just here, I will just or 1 equals 1. Okay, I triggered a security event. Perfect. I will go now to my traffic logs. And now you can see that the source being or accessing my web server is the 10.1.1. And this is the firewall. You see that I can no longer see the real IP. If I go to the attack, you can see that the attack is generated from the 10.1.1.254. Guys, who can tell me what can be the major issue with that? What's the major issue in FortiWeb? When you cannot see the real client IP, but you see the traffic coming from the firewall. What do you think?
Maybe dropping all the traffic coming from the firewall.
Thank you so much, Abdelkader. It's a really nice answer. Guys, Abdelkader is saying, from the WAF perspective, everything is coming from the firewall. So the WAF doesn't see anything but a firewall sending all the traffic. So everything coming is from the 10.1.1.254. What if your WAF decides to block or blocklist a specific client. What if a real client is a hacker and you decided to put it in quarantine for 60 minutes? And this is a feature in FortiWeb. When you detect someone trying to send web malicious attacks, you can decide to quarantine this guy. If you do that, whenever the FortiWeb detects a malicious traffic, the FortiWeb blocks this IP, which means that even the legitimate users will lose access. The WAF sees that every single HTTP packet is coming from the firewall, and the firewall is being blocklisted. So you lose access to your application at all. Okay? No one can access your application anymore. So what's the solution, guys? And this is the scenario 2. I have to go to the firewall and configure it to add the X forwarded for. This is the first step. Then I go to the FortiWeb and I configure it to use the X forwarded for that have been received. So add it in the firewall, use it in the WAF. How to do that? You will see that it's very, very easy. I will start with my FortiGate. In the FortiGate, when you go to the virtual server configuration, just click on Preserve Client IP. This feature is in reality, it's in the GUI just for basic users. But in reality, it's the X forward for. It's add X forward for. Just click on this option. So I will click OK. It's done. Then I will go to my FortiWeb. And if I try again, you will find that the FortiWeb receives that, but it will not use it. Why? Because maybe someone is just injecting the X forwarded for and it's not authorized. Now, to configure the FortiWeb to accept that, go to your X forwarded for configuration, the same object I used to add. I will say use X header to identify original client. And I want you to use the header called X forwarded for. Now, by doing that, the FortiWeb use it for monitoring. But if you want the FortiWeb to never block the source IP, but it will block the X forwarded for IP, you have to enable this feature. Block using original client's IP. If you don't enable that, the FortiWeb can see the IP, but still drop the IP from the firewall. Never forget to enable both. When you do that, you have to configure also the list of source IP addresses that you trust. What is the device that you trust X forwarded for from? It's the firewall. So add the firewall IP address. By adding this IP, you are telling your FortiWeb, whenever you receive X forwarded for from that IP, you can trust it. No problem. Now, by doing this, remember, the firewall is adding the X forwarded for, and the WAF is reading it and using it to block. Now, if I try again, I will just go and I will just try the exact same access. Oh, yes, like this. One equals one. You see, it's blocked. I will go to my attack logs. And now, again, I can see the real client IP. So guys, what can be very, very interesting, the FortiWeb from the attack perspective sees the traffic coming from the client. But from the networking perspective, if you go to the traffic logs, you will see that the traffic is still coming from the firewall. So the traffic logs see traffic coming from the FortiGate, but the attack logs see the traffic coming from the client. And this is exactly what we wanted to do. Do you have any question, guys? That was the end of the demo. Any question? Yes? Abdurrahim?
Hello, sir. I hope you're doing okay. Thank you for your time.
Thank
And
you.
I'm sorry for being late. As the website says that today's session is on 9:30 and not 7. So I'm wondering if we can find the recording of this session. Thank you.
Sure. Yes, it will be made public, I think in the next 2 days by the OWASP team.
Okay, thank you so much.
You're welcome.
Honestly, Mehdi, thank you so much for this presentation and this informative session. I had some question, but the time is up.
Yes.
I had some question, but the time is up. I wanted to see me and the audience how to do some mitigation strategies. For example, so since we are using the WAF to protect web application, we know that the attackers are also updating their tools and techniques. So there's also some bypasses to, for example, as you did here, a payload. Sam, tomorrow we will have another payload. So how we can in the Fortinet, so we are using the Fortinet in the FortiGate or the Fortinet WAF, how we can mitigate those risks and create a customized policies for these attacks, if this is possible. Otherwise, we can
Okay.
let it for another session.
Okay. In a very pretty and nice way. How to answer the question. First and foremost, what we used in the 2 sessions was just very, very basic configuration. We just provided access and we used a simple web protection profile. If you take any web protection profile, if I go to policy, web protection, you will find an extensive list of features. Every single feature requires deep understanding about the web attack you are mitigating and how to configure it. So here you can see just a list. You can use signature-based detection. You have the HTTP protocol constraints that will use the HTTP RFC to validate the body, the headers, something like that. You can have some security on the cookies. You see many, many features. Every single one can be an answer to your question, but it depends. But what I want to explain especially is the capability of the FortiWeb and almost all the modern WAFs to mitigate attacks using machine learning. If I go, for example, to my server policy that we created, when you go down, you can see the machine learning feature. This enables the WAF to learn every single URL and every single parameter inside the URL. You know that an application is, to make it simple, a set of URLs with parameters. And every parameter represents an input to the application. So whenever you say a parameter, it means there is a possibility of injection. Now, the machine learning in the WAF helps the admin to get a huge list of all the parameters. Some applications have hundreds of thousands of parameters and know exactly what is the pattern that is accepted on every single parameter. Just to give you a very simple example. If I have in my web application a parameter called product ID, that's just an example. This product ID in my application is always a string, is always an integer, like this. For example, I have a product ID 111-222. The FortiWeb can learn this using its machine learning capabilities, and it can know the deviation from the model. For example, if someone is trying to inject something like select from on a product ID, the machine learning model knows that this is an anomaly. It's not possible to have the string select from on the product ID parameter. Why? Because from the machine learning model, we knew that 99.90% of the product IDs are integers. And this is why the machine learning can help you automatically mitigate and even zero-day attacks. Make sense?
Yep, it's a very important option. Thank you so much, Mehdi.
You're welcome. I would be happy to explain more and talk to you about more features, but we're limited by time, and I hope that it's enough to at least understand the global idea.
I think the student has the session. Maybe we'll program another
Okay.
session for future, inshallah.
Okay, inshallah. So I hope that you enjoyed the two sessions, and I hope to see you, inshallah, in another training or any other meeting.
I have a question, please.
Inshallah.
Yes, Tawfiq? Or it's Abdul Qadir?
Sorry.
Yes?
It's Abdul Qadir, yeah. What if a packet came with an XFF in its HTTP header? What's the firewall reaction in that case?
The WAF, you mean? You mean the WAF?
Firewall, because it's firewall, the FortiGate, yeah.
It depends. If you didn't configure, for example, if you didn't configure the WAF or IPS in the firewall, it will pass. But if you decided, I told you that there is a small WAF that you can enable in the firewall. It's a limited WAF, and it depends on the complexity of the SQL injection. If you enabled WAF and IPS, the firewall maybe can detect it. Okay? So it depends on your configuration.
Okay, thank you.
You're welcome. Okay, guys. So again, thank you so much for being part of this experience. Thank you for all the questions, all the, you have been involved. You made the session very interactive. And this is what I like the most in my training sessions. I hope to see you, inshallah, in other sessions, maybe other opportunities. And in the meantime, take care and salam alaikum.
Salam wa rahmatullah. Thank you so much, Mehdi, for this informative session and sharing this expertise and awareness through these concepts of web security. Thank you so much. Team, once again, thank you all for joining us today. Don't forget to stay connected for more exciting upcoming session from OWASP Algiers chapter. See you soon, inshallah. Thank you so much, team.
Thank you.
Thanks.